Hi, welcome. In this video, we will solve problem rotate image asked by companies like Amazon, Microsoft, Facebook, Google, Apple, and Uber. Let's check out this problem rotate image. Okay. If you are practicing your 2D arrays, your 2D matrix concepts, this is the most important problem on 2D arrays. Okay. If you really want to be good in implementation, that means you are clear with the logic, but you don't know how to implement it, you can put this problem into your bucket list. Okay. So let's see what is this problem. That is the rotate image. Okay. Think like a real problem. Basically, suppose in your image viewer, okay, in your mobile, if you want to rotate your image, how you rotate it? Basically, you simply flip it, rotate it by 90 degree, 180 degrees. But how, what is the code behind it? How it got rotated, right? So we will learn today. Basically, these numbers, you can take these as a pixels. Okay. How I will simply rotate pixels. Let's see this problem. So you are given an n cross n 2D matrix. So n cross n, here the n is 4 cross 4 2D matrix representing an image. Rotate the image by 90 degree. So I just need to rotate the image by 90 degree clockwise direction. Okay. So you have to rotate the image in place, which means you have to modify the input in 2D matrix. Okay. So the input should be in 2D matrix directly. Do not allocate any another 2D matrix. So basically it should be in place. Okay. We don't need to take any extra size for it. Okay. We won't create any extra matrix for it. We will do it in place. Okay. We just need to modify the 2D matrix. That's it. So let's see, this is my image. Okay. And if I want to rotate this image, so let me rotate it 90 degree and let me put this in and let me create one copy of image and let's rotate that one. So if I rotate this 90 degree, it will be look like something like this. This is my rotated image. Okay. By 90 degree. Okay. So basically this image will be exactly like this. 15, 13, 2, 5, 14, 3, 4, 2, something like this, right? So this is what we need to do, right? We basically need to rotate in place. In place. That means we don't need to take any extra space. Okay. So here you can see this was my row, right? 5, 1, 9, 8. Now this is here, right? 5, 1, 5, 1, 9, 11. It's now become column. The first row will become the last column. The second row will become the second last column, right? The third row will become the third last column and the last row will become the first column. Okay. It is like this one. Now how we will do it? How we will do it? Let's understand by one. So let's understand by the approach one, that what we can do here. So basically this is my image and I want to rotate it. So let's understand it. So basically what I want, this will be the final image, right? This is the final result. Let me put this as an answer. Okay. What I want, what I want here, let's see, let's understand. And let me add the indexes as well. Okay. So that we will get a better clarity. So 0, 1, 2, 3, 0, 1, 2, 3. Okay. These are my indexes here and here. So what I want here, that is, sorry, what I want here. So here I want 15, right? 15. So basically 15 is here. 15 is here. So I want that my 15 from here, it should move here, right? So this is filled by 15. Okay. Now if 15 is moved here, what I want this to be filled with? Okay. So this to be filled with 16. So where is 16? 16 is here. So it should move here. Now if 16 is moving here, by which element should I fill this? 11, right? 11 we have as an answer. So I want 11 to be shifted here. And if 11 is shifted here, by which element I should fill this one? So this will be filled with 5. Similarly, right? If I want to, what element which type of element I want here? Here I want 13. Where is 13? Here is 13. So I want 13 to be here, right? Now if 13 is there, so which element will fill this space? It is filled with 12. Where is 12? So I want 12 to be filled with this space. Similarly, 10 will fill the 12th space, and 1 will shift here, right? So this is how I want to basically fill it. Okay, so let's understand how I want to fill it. So I want that my 0th space, okay, my 0th space, that is 0 comma 0, should be filled by an element that is at n minus 1, last row first column, column, right? N minus 1. So let me write it something like this: n minus 1 comma 0, right? So I want my 0 comma 0 place should be filled with 15. This is I want. So basically you can see I want 15 to be here, 16 to be here, 11 to be here, 5 into here. Basically what I am doing swapping. Okay, if you studied swapping, what are swapping? Basically, if I want to swap A and B, how I will swap it? Okay, suppose the A is pointing to 4, B is pointing to 3. What I want as a result, my B should be pointing to 4, A should be pointing to 3. So how I will get it? I can achieve by a third variable. I can simply take temp. Temp will store A will store B, and B will store temp, right? So by this thing, you can basically do a swap between A and B. See, temp will have 4, A will become B is 3, so A will become 3, and B will become temp. So what is temp? Temp is with 4, right? Similarly, you can now, by the same logic, you can swap 3 elements. Temp will be A will be B will be C, and C will be temp, right? Similarly, what we will do, we will swap 4 elements, right? So this is for 2 elements, this is for 3 elements, okay, and we will do this one for 4 elements, right? So what I want, that my 0th comma 0th place will be filled with an element that is at n minus 1 and 0, right? What I want then, n minus 1 0 comma, like this element will be filled with 16, right? And what is the position of 16? That is 3 comma 3 last. So can I say n minus 1 comma n minus 1? Basically I am taking cross n, that is 4 cross 4, right? So that's why I am writing n minus 1 comma n minus 1, that is 3 cross 3, like 3 comma 3, right? And that's why n minus 1 comma 0, that means third row, the last row, and first column. Now what 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 element should place 16, 11, right? So n minus 1 comma n minus 1, this space to be filled with 11. What is 11? That is 0 comma last column, 0th row, last column. So 0th row, last column, that is n minus 1 again. Now what will be filled by 0th row and last column, n minus 1? That will be filled by the first 0 comma 0, right? So what we will do, here we will do the same thing. We will store in temp, okay, and I will store temp 0 comma 0, right? This position, right? Then 0 comma 0, and instead of putting 0 comma 0 here, because the value will be replaced, I will simply put temp here, right? So this was for these 4 positions, right? These 4 positions will be swept, okay, but we need to change a lot, right? We need to change all the positions. So let's see, let's create a logic for it, and we are building a logic, right? I Here I am doing simply statistics, right? 0 comma 0 should be filled with n minus 1 comma 0, but let's come up with some variables, come up with some generic terms. Okay, so let's understand one more scenario where the 0 comma 1 element I want to fill with 2 comma 0 element, and then 2 comma 0 element I want to fill with the 3 comma 2 element, right? So let's see, let's understand this one. So the 0 comma 1 element I want to fill with which one? 2 comma 0, right? So what is this 2? Can I say n minus 2, right? The second last row, that's why n minus 2, second last row, right? So it is n minus 2 comma 0, right? Now n minus 2 comma 0 I want to fill with which one? Can I say the last row and second last column? The last row and the second last column. Now the last row and second last column I want to fill with 12 with 10. Can I say second row, last column? Second row, last column, that is 1 comma n minus 1. Now 1 comma n minus 1 can be filled with 1 comma n minus 1 can be filled with 0th row first column, right? The same thing. Again, here also we will use temp, right? Basically, we need to swap them. So we want a third variable. So temp will be 0 comma 1. And in the last, what we will do, I will simply put temp here. Okay. Now let's see, is there any generic term that we can use instead? These are constants, right? These are constants. But is there any generic term that we can use so that we can simply swap all these elements, right? Swap all these elements. Is there any generic terms that we can get from here? Let's understand it. Let's understand. Let me create an space here. So, so what can be the generic term here? 0 comma 0. Let's try to create it by I comma j. Okay. So here, if I am putting I comma j, I comma sorry, I comma j, right? So here I comma j will be 0 comma 0, and if I put I comma j here, so here I will be 0, j will be 1, right? Here I and j both are 0. So can I write this one 0 comma 0 or 0 comma 1 in a generic term I comma j? That I comma j 0 comma 0 I will place with n minus 1 comma 0. Can I write this as n minus 1 j comma I? Why am I writing n minus 1 minus j, not I? Because see, here j is 1, here j is 1, right? I is 0, j is 1, and here I am getting n minus 2 as a result. So how I will get n minus 2 as a result? When I do n minus 1 minus j, where j is equals to 1, so this result will be n minus 2. That's why I have written n minus 1 minus j. Now n minus 1 minus j, comma I want to replace this one with n minus 1, n minus 1, n minus 1, n minus 2. That means, can I say this is nothing as n minus 1 minus I, comma n minus 1 minus j, right? Because here j is 1. So that's why it is n minus 2. Now n minus 1 minus I, comma n minus 1 minus j, I want to fill this one, which element? 0 comma n minus 1, 1 comma n minus 1. So can I say here 0, here 1, that means this is j, and here n minus 1. So can I say this is n minus 1 minus I only, because I is 0, right? Now j comma n minus 1, j comma n minus 1 minus I, what I want to be filled with, basically I comma j. So I can put temp here, right? And in the temp I will basically store I comma j. So these will be my terms. These will be my terms. If you fill I comma 0, you will I 0 j I 0 j 0, you will get this term, exactly this term. If you fill I 0 j 1, you will get this term. So this is a generic term. This is a generic term that we have derived from observing the values, right? See, 0 comma 0, this will become n minus 1 comma 0, n minus 1 comma 0. If I put 0 comma 1, so 0 comma 1 will become n minus 2 comma 0, n minus 2 comma 0. You can take anything. Suppose we have this one, last one, j comma n minus 1 minus I. If I put j 0 and I 0, so it will become 0 comma n minus 1, 0 comma n minus 1. If I put j1 and I 0, so 1 comma n minus 1, 1 comma n minus 1, right? So I have created these terms. So let's understand. Okay, let's understand. Once I have created this term, and if I'm taking this image, so let's see. So let me create here indexes again. So 0, 1, 2, 3, 0, 1, 2, 3. Okay. So if I want to replace this one with this one, this with this with this, here 16, 15. So these all elements are done. Can I say these elements are done? Let me use this pen. And this one, and this one done, right? Similarly, right, if I work on this one, like I want to replace 0 comma 1 with the 13, right? So this is done, this is done, then this is done, and this is also done. Okay. Now, if I want to, like, if moving ahead, similarly, this will replaced with this one, this one, this one, and this one. Can I say this is done, right? So basically how I am doing, I will start from here, that is 0 comma 0, right? And I will go till here only, right? That means last, not last, second last. Okay. Why second last? So here I am starting from 0 comma 0 and I am going till 0 comma 2 only, right? To basically I need to work on these three elements, right? And then I will simply run my this swapping code, right, of four elements, and I will swap all these elements, all the boundary elements, right? So basically if I put this also in generic term, it is starting from when j is 0 and it is going till I is 0 only and j is 2. So can I say j will run till n minus 1 minus I? Okay. And not even n minus 1 minus I, right? It will be less than that. Okay. It won't go to the last because n minus 1 minus I will be pointing to. It will be n minus 1 minus I and minus 1 because this is the last, right? It will start from here, but it will run till here only 0 to 2. Okay. So if I say that less than n minus I, okay, less than n minus I, my j will be less than n minus 1 minus I. Okay, that means starting from 0 and going till n minus 1 minus I, this one. Now, what are the remaining elements? What are the remaining element? This is the remaining element. And if I swap this one, let's start. If I swap this one, 4, not take this color, let's take this color, right? So what will happen? Let's see in this figure, right? 3 will come here, right? And 4 will come here, 8 will come here. Basically, there will be one swap. So basically, these four elements will also be swapped automatically. I just need to swap one element. Okay. So let's see from here. Okay, we are going till middle of the matrix. We are going till the middle of the matrix. So in a row wise, okay, if I'm taking row, I am starting from I equals to 0 and I'm going till simply I less than n by 2, right? Floor value of n by 2. Okay, I'm going simply less than n by 2. What is n by 2? That is, this is 4 cross 4. Okay, so this 4, if I put 4, it will become 2, right? So I will be less than 2, right? Because I reaching to 1 only. Okay, half of the matrix. But my j is starting from in column, my j is starting from 0 and it is going j is less than n minus 1 minus I, right? So we have identified like what will the iteration of I, what will the iteration of j. So we are good to move to the pseudo code. Let me write the pseudo code of it. Okay, so what will the pseudo code? Let's see. So basically I will start from I equals to 0 and I will run, as I have mentioned, less than n by 2. So I will run till method.floor, basically the floor value of n by 2, where n is the size of the matrix, and I plus plus. Then what will happen? For j will start from I, right? You can see here my j will start from here. When I is 1, j will also be 1. Even if you take a 5 cross 5 matrix, this will be the same, right? It will start from j equals to I, j less than n minus I minus 1 and j plus plus, And now what we will do, we will pass all our four conditions that we have discovered, right? What are my four conditions? So basically what I want, my temp should store my matrix. Okay, let me call mat only. My mat of I comma j. Okay, and then mat of I comma j, as we have checked, I comma j will go to n minus 1 minus j comma I, right? So it will be n minus 1 comma j comma I. Now mat of n minus 1 comma j is n minus 1 minus j comma I will be replaced by mat of n minus 1 minus j, n minus 1 minus I, right? So n minus 1 minus I comma n minus 1 minus j, then mat of n minus 1 minus I comma n minus 1 minus j will be replaced by mat of j comma n minus 1 minus I, and the last mat of j comma mat of n minus 1 minus I will be replaced by temp. Yeah, that's it. This will be, these are all our four conditions that we have drawn from here, right? These are all four conditions, right? We have done, and we are good to go with the pseudocode. Now what will the time complexity here? So here, let's see, this loop will run for n by 2 times, and what like how many times this will run, right? So here it is running from I to n minus I minus 1, right? So suppose when I is 0, okay, it will run how many times? N minus 1 time, right? When I will be 1, how many times it will run? N minus 2. And I will be 2, it will run by n minus 3, right? And so on, right? It will go up to 1, right? But it will go up to 1 when I is equals to n, right? Then it will become n minus n minus 1, right? So then it will become 1, but it is going half of it, right? So the total time complexity, right, if I derived, okay, it will be around n square, right? Basically if I do the summation of n into n plus 1 by 2, right, this will be the total time complexity. If I simply, let's, for a minute, let's don't assume n by 2. Suppose I is running from 0 till n, right? So then the time complexity will be n into n plus 1 by 2, but it will be run n by 2, right? So if I basically replace n to n by 2, right, so it will be n by 2 plus 1, right, 2. So even if I am doing this one, so it will be something as n by 4 into n plus 2 by 2, right? So yes, it's some around n square plus 2n by 8, okay? And if I'm ignoring the constant and the smaller terms, so it will be around n square. Ultimately, it will be very less than n square because it is divided by 8, but it will somehow be called as big O of n square only. So here the time complexity is big O of n square, okay, and we are not taking any extra space, so the space complexity is big O of 1, that is constant, okay. So time complexity big O of n square around n square, okay, although it's n square by 8, you can say, if you are ignoring constant, okay, this will be the time complexity. So yeah, this is the one approach that we can apply. Let's understand one another approach that we can come with. So let's discuss approach 2 here. Let me copy the figures. So let's see here. So we have this column, okay. Let's understand this column, this zeroth column, right? So we have zeroth column. Can you check this zeroth column? Basically, in my answer, this zeroth column is here, right, as a zeroth row, but in reverse fashion. In a reverse fashion, basically 5 to 13, 15, 5 to 13, 15 in a reverse fashion. You can check your first column 1 4 3 14 it's here as a first row, but in reverse fashion, right? So your column is represented as row and then it got reversed, right? Your column is represented as row, but it got reversed. So basically, what is this column to row? When we change from column to row or row to column, okay, transpose, correct? Transpose. We have already solved one problem of transpose of a matrix, right? So if I do the transpose of this matrix, how it will be look like? Let's see. So I am taking one blank matrix, and if I do the transpose of it, how the transport happen? Basically, what you will do, you will swap the elements from its diagonal, right? So if this is diagonal, 1 comma 2, 1 comma 2 will swap, 13 and 9 will get swapped, 15 and 11 will get swapped, 3 and 8 will get swapped, 14 and 10 will get swapped, 12 and 7 will get swapped, right? And these will swap, right? Basically, so we will get a transpose of a matrix. So basically this column will become a row. This column will become row. Let's see. So 5 to 13, 15. If I transpose, I will get 5 to 13, 15, right? Like this. And then we have 1, 4, 3, 14. It will become again a row. 1, 4, 3, 14. 9, 8, 6, 12. 9, 8, 6, 12. Then 11, 10, 7, 16. 11, 10, 7, 16. So you can see basically what you have done. You have done the swapping from the diagonals. 2, 1, 1, 2. 9, 13, 13, 9. Right? 3 and 8, 8 and 3. Right? So this is, you got this transpose of the matrix. This is the transpose. Now from transpose, if I basically reverse it, if I reverse it, I will get this one. What I need to do, I need to reverse row, basically reverse row. If I reverse the zeroth row, what I will get? I will get 15 3 2 5, 15 3 2 5. If I reverse it 1 4 3 14, I will get 14 3 4 1. Yes, right. So basically now what I will need to do, I need to reverse it. Okay. So yeah, this is also one approach, that what we can do, we can first find the transpose of the matrix. We can first find the transpose of the matrix. And then what we can do, we can reverse rows of the matrix. Yes, right. So basically, how, what we need to do, we already know transpose of a matrix. How we need to do, basically, what I want this, this 0 comma 1 will become 1 comma 0, right? 0 comma 2 will become 2 comma 0, right? This 2 comma 0. Let me write this one here. 2 comma 0 will become 0 comma 2. 3 comma 0 will become 0 comma 3, right? So this will be my transpose logic. What I will do, I will basically simply do a transpose and then I will simply reverse the rows. So let me write the pseudocode of it. Let me shrink so that I will get the space. So my logic will be basic, this transpose of a matrix, then reverse rows of the matrix. And let me decrease the size of it. So let's see, let's understand how we can write the, how we will write the code of the transpose of a matrix. But basically I need to transpose only these elements, right? These elements. Then if I basically swap these elements, I will get the transpose of the matrix. Okay. So here you can see my I, if I take I and j pointer, okay, my I will start from 0 and it will go till the last of my row, right? Last of my row, or I will say second last of my row, not even the last of the row. Second last of row, it will go. Okay. So I will say that less than n minus 1 I want. And here my j will start from 1, not I, right? When I is 0, it is starting from 1. When I is 1, j is starting from 2. When I is 2, j is starting from 3, right? So can I say my I will, first of all, my I will start from 0, okay, and it will go till My I will start from 0 and it will go till n minus 2, right? My j will start from I plus 1, right? See, when I is 0, when I is 0, j is 1. When I is 1, j is 2. When I is 2, j is 3, right? So it will go I from I plus 1 and to the last, because it is going to the last element, completely last. So j will be less than n. Yes. So this is the logic, right? These will be the basic iteration limits for the transpose of the matrix. Let quickly transpose it. So let me write the pseudo code of it. So for I will start from 0 and I will go till n minus 1, less than n minus 1. Okay, if I am writing less than n minus less than n, then it will be go till n minus 1. I plus plus for j that will start from I plus 1 to j is less than n, and j plus plus, and then what I will do, I will simply write the logic of my transpose, that I will take one temp, and in temp I will say met of I comma j. Okay, then met of I comma j will put met of j comma I, right? Met of j comma I will put temp, this one, right? So basically this will be the logic, right, of transpose. Basically this is for transpose of the matrix. Okay. Now once the transpose is done, what do you need to do? You need to reverse rows. So I will say simply what you will do, you will start from 0 to the last row. Okay, can I say n and only n, and then I plus plus. What you will do, you will simply reverse the row one by one. So I will call my reverse function, and you will do reverse of matrix of I. Basically matrix of I means that I am giving one array and you are reversing it, right? How reverse will happen, right? Reversing will happen. Let me show you. That is also very right easy. So suppose this is your row, right? You will pass one by one row. Okay, it is not giving me a screenshot of it. So let's take a screenshot. So here you can see this is my one array, right? Basically you will pass this array, right? So how we will reverse it? Again, let's think that this is one array, treat is like an array, right? And you will reverse it, right? So how you can do it? You will simply call reverse function. If you don't have reverse function, you can take two variables L and R, where L is pointing to 0, R is pointing to the last element of the array, that is n minus 1. Okay. Now what we will do, we will swap this one. We will swap 5 with 15. How we will swap it? Again, we will swap like this one. Temp will be ARR of L. Okay. And ARR of L will be ARR of R. Array R, and array R will be, that is temp. So we will swap them, and once we swap them, then we will move the pointer L and R. Then we will swap these two elements and we will move the pointer L and R. Right? Once both the pointer crossed each other, once my L is greater than R, I will stop it. I will stop it there, and this is how we will swap the elements, right? It can be entire row. It can be entire row, but this is how we will swap the elements. So let me write the code of a reverse function if you want. That will be like basic this one only. So how this will be code of a reverse function. So suppose I have this function reverse, okay, where you are passing one array, okay, your matrix row basically, where L is at 0, R is at n minus 1. You will run a while loop till L is less than R. What you will do, you will swap them, right? So in temp, you will store L. In L, you will store R. In R, you will again store temp, right? Yeah, this will be done, and let me move ahead a little bit. Code. And here what we want both pointers to be moved, so L plus plus and R minus minus. Yeah, that's will be the logic for reverse function. Okay, what will the time complexity here? So let's quickly analyze. Okay, it is running for n minus 1 times, right? This is running for I plus 1 to n times, right? So when I 0, it will run from 1 to n. When I will be 1, so it is nearly, this will also run for, I will say, like this both will run for n square times, because see 1 to n time first, then 2 to, like, from 2 to n times, so it will become, first time it is running n minus 1, then n minus 2, and so on till n, so then it will become n square. Now this is running from 0 to n, right? This reverse wala function, right? So it will also run for n times, basically for all the rows inside this reverse function. Okay, there are n elements, so it will take only n by 2. Basically L is starting from 0, R is starting from here, so it will take only n by 2. So we have n square plus n plus n by 2. Okay, that is also nearly n square. So here also the time complexity, where should I write it? I'm not getting any space. The time complexity will be big O of n square here as well, right? Nearly n square. Okay, the space complexity again constant, so it will be big O of 1. So that will be the time and space complexity. Here the pseudocode. In the next video, I will give you a complete implementation of the problem of both the approaches. We will see, and in the next video we will check out the dry run of it.